Good evening. Exercise 3.6, sum number 26. 5 students are selected from 11. How many ways can these students be selected if A. 2 specified students are selected, B. 2 specified students are not selected? Okay, write down. We have to select, write the solution. We have to select 5 students from 11. We have to select 5 students from 11. Now, A part, 2 particular students are selected. Two particular students are selected. Write down. Therefore, 3 more students are to be selected. Therefore, 3 more students are to be selected. Therefore, 3 more students are to be selected from the remaining 9 students, because selected students cannot be selected again. From the remaining 9 students. Therefore, total number of selections equal to. Therefore, total number of selections equal to. Write down. It is what? 84. Write down. Second part. Two particular students are not selected. Write down. Therefore, 5 are to be selected from 11 minus 2 equal to 9 students. Therefore, number of ways equal to what? 9C5. So 9 factorial upon 4 factorial into 5 factorial. So once 5 factorial gets cancelled, 6, 7, 8, 9. And what is 4 factorial? It is 24. So 14 into 9, that is 126. So this is the answer. Write down. Miscellaneous exercise 3. It is actually question 1. Select the correct answer from the given alternatives. First MCQ. A college offers 5 courses in the morning and 3 in the evening. The number of ways a student can select exactly 1 course either in the morning or in the evening. Or means addition. So 5 plus 3 equal to 8, which is given in option C. So C, Calcutta is the correct option. Let me explain. Second, a college has 7 courses in the morning and 3 in the evening. The possible number of choices with the student if he or she wants to study one course in the morning and one in the evening is there. So product 7 into 3, 21. Correct option is A, Ahmedabad. Third one, in how many ways can 8 Indians and 4 Americans and 4 Englishmen can be seated in a row so that all persons of the same nationality sit together? Let me explain. We consider persons of one nationality as one group. So we have to arrange 3 groups which can be arranged in 3 factorial ways. Now, 8 Indians can be arranged in 8 factorial. Then 4 Americans in 4 factorial and 4 Englishmen in 4 factorial ways. So by fundamental principle, total number is 3 factorial into 8 factorial into 4 factorial into 4 factorial, which is given in option B. Fourth is an important MCQ or can be asked as some in college exam. In how many ways can 10 exam papers be arranged so that the best and the worst papers never come together? Without considering complement also this can be solved. But here I have considered best paper and worst paper as single paper. So this paper and remaining 8, that is 9 papers can be arranged. See the cursor. In how many ways? 9 factorial ways. Now 2 papers, the best and the worst, can be arranged among themselves in 2 ways. So in these many ways, 2 into 9 factorial, the best and the worst papers will always come together. If there is no restriction, total number of arrangements is 10 factorial. But out of these 10 factorial arrangements, in these many arrangements, the best and the worst papers are always together. So the difference gives number of ways in which they are never together. I can take 9 factorial common. 10 factorial is 9 factorial into 10. So in bracket 10 minus 2, that is 8. So 9 factorial into 8. Correct option is D, Delhi. Last one means 5th one, so that you can write the solutions. In how many ways 4 boys and 3 girls can be seated in a row so that they are alternate? See, number of boys is not the same as number of girls. They are supposed to sit alternately. So arrangement is to begin with a boy. Then only they can be arranged alternately. So boy, girl, boy, girl, boy, girl, boy. So 3 girls and 4 boys. Now 4 boys can be arranged in 4 factorial, that is 24 ways. 3 girls in 6 ways, 3 factorial. So by fundamental principle, total number of arrangements 24 into 6, that is 144. It is given in option C. Sum number 6. Find the number of triangles which can be formed by joining the angular points of polygon of 8 sides as vertices. So 8 non-collinear points, 3 non-collinear points determine the triangle. So 8 points will determine 8C3 equal to 56 triangles, which is given in option B. Let me explain. 7th, question paper has 2 parts, A and B, each containing 10 questions. If a student has to choose 8 from A and 5 from B, find number of ways. Simple. 10C8 into 10C5, 45 into 250. 11340. Correct option is D, Delhi. Sum number 8. We will not solve this right now, but if you have done circular permutation on your own, answer for 8th is B, Bombay. Similarly, 10th is on circular permutation. We haven't done that, but I have given the answer D, Delhi. 9th we can solve. The number of arrangements of the letters of the word banana in which 2 ends do not appear adjacently. See, if there is no restriction, the letters in the word banana can be arranged in how many ways? Banana is a 6-letter word in which A occurs thrice and N occurs twice. Let me explain. So number of arrangements is 6 factorial upon 3 factorial into 2 factorial. Okay. Now what is asked? Two n's do not appear together. So we will find number of arrangements in which they do appear together. So consider two n's as a single letter. So that letter and remaining 4. So 5 letters can be arranged in how many ways? 5 factorial upon 3 factorial. Why upon 3 factorial? Because a occurs thrice. So out of these 60 ways, in 20 ways, they are together. So in remaining, that is in 40 arrangements, two n's do not appear together. So correct option is C, Calcutta. Now, second question, answer the following. First part for homework. Find the value of R if 56PR plus 2 is to 54PR minus 1 equal to 30,800 is to 1. So, answer is R equal to 45. Second, how many words can be formed by using letters in the word crown in different order? Now, crown is a 5-letter word, not a single word is repeated. So, number of arrangements is 5p5 equal to 5 factorial equal to 120. Now, third one, yes, we are going to solve that, but not today. I'll give you time to think on the solution part. It is interesting. Let me read third one. Find the number of words that can be formed by using all the letters in the word remain. If these words are written in dictionary order, what will be the 40th word? Try. Fourth one. Capital English alphabet has 11 symmetric letters that appear same when looked at in the mirror. These are A, H, I, M, O, T, U, V, W, X, and Y. How many symmetric 3-letter passwords can be formed using these letters? Order is important. Now, 11 distinct, of which 3 are to be arranged. So, 11P3, that is 990 passwords. Right now. Fifth one. How many numbers formed using the digits 3204, 323 exceed 1 million? 1 million means 10 lakh. Don't write, let me explain. See, digits are what? 3204323. Degree of difficulty is increased because 0 is included and 3 occurs twice, 2 occurs twice. Okay. Now, any number greater than million will contain all these 7 digits. So, how many numbers can be formed? Suppose initially we do not consider, rather initially we do consider 0 and then we'll subtract numbers in which 0 appears at the extreme left. So 7 digits can be arranged in how many ways? Don't write. I'm explaining. 7 factorial upon 3 appears thrice upon 3 factorial into 2 factorial. Okay. So what is that number? 7 factorial, we know it is 5040. 3 factorial is 6 into 2 factorial is 2. So 12. 5040 upon 12. So 12 4s are 8. So 420. Do you agree with me? Now all are not what can we say, 7-digit numbers, because if 0 appears at the extreme left, it is 6-digit number. Okay, so from this we have to subtract certain number of numbers. How to decide that? We write 0, we keep that digit fixed at the millions place. So remaining 6 digits can be arranged in how many ways? 6 factorial upon 3 factorial into 2 factorial ways, because again 3 occurs thrice, 2 occurs twice. So this number is 720 upon 12, that is 60. So in 420 minus 60, that is 360 numbers, we can say that they are definitely greater than 1 million. Write down. Write the solution. Given digits are 3, 2, 0, 4, 3, 2, 3. A number greater than a million, that is 10 lakh, a number greater than a million, that is 10 lakh, will contain all the 7 digits, will contain all the 7 digits. Next line. Of these 7 digits, 2 repeats twice and 3 repeats thrice. 2 repeats twice and 3 repeats thrice. Therefore, total numbers formed using these digits equal to. Therefore, total numbers formed using these digits equal to. See on the screen. 7 factorial upon 3 factorial into 2 factorial equal to this, equal to 420. Just write this much, 420. Next line. In some of these arrangements, 0 is at the millions place. 0 is at the millions place. Such numbers are not greater than a million. Such numbers are not greater than a million. We keep 0 at millions place. We keep 0 at millions place. Then remaining 6 digits can be arranged. Then remaining 6 digits can be arranged in 6 factorial upon 3 factorial into 2 factorial. See on the screen. 6 factorial upon 3 factorial into 2 factorial equal to 60 ways. Next line. Hence, total numbers formed total numbers form exceeding 1 million equal to total numbers form exceeding 1 million equal to 420 minus 60 equal to 360. Sum number 6. 10 students are to be selected for a project from a class of 30 students. There are 4 students who want to be together, either together either in the project or not in the project. Find the number of possible selections. So 2 cases we have to consider, that all of them are there, all of them are not there. Now there are 30 students and 10 students are to be selected for a project work. 4 students decide to join the project work. If 4 students decide to join the project work, then from the remaining 26 students, we have to choose 10 minus 4, that is 6 students. This can be done in how many ways? 26 C6 ways. Actually, in exam, you can keep this as it is, 26 factorial upon 6 factorial into 20 factorial. But here they have found the value. Second possibility, 4 students will not join the project. If they are not joining the project, means 10 students are to be chosen, but not from 30, from 26. So this can be done in how many ways? 26 C10 ways. Here they have found the value as this. So what is total number? It is addition of these two. So this is the answer. 55 lakhs 41,965. I think in exam you can say 26 factorial upon 6 factorial into 20 factorial plus 26 factorial upon 10 factorial into 16 factorial. 7th, a student finds 7 books of his interest but can borrow only 3 books. He wants to borrow chemistry part 2 book only if chemistry part 1 can also be borrowed. Find the number of ways he can choose 3 books that he wants to borrow. Okay. There are 7 books of interest and only 3 can be borrowed. Suppose chemistry 1 book is selected, then chemistry 2 book can also be selected or is to be chosen. In all, 3 are to be selected. So third is to be selected from remaining 5. In how many ways? 5C1 equal to 5 ways. So this is the first part. What will be the second part? He wants to borrow chemistry part 2 book only if chemistry part is borrowed. Suppose chemistry part 1 is not borrowed. So part 2 is again not borrowed. So 3 books are to be borrowed from remaining not 7 but from 5. So that can be done in how many ways? 5C3 equal to 10 ways. So total number is 5 plus 10, that is 50. First write down this much. So write down this. Same, I have already explained. If chemistry, they say chemistry 1 is not available, so student can't borrow chemistry 2, but still 3 are to be borrowed, but from remaining 5, so 10 ways. So considering 1 and 2, total number of ways is 5 plus 10, that is 15. Sum number 8. 30 objects are to be divided in 3 groups containing 7, 10 and 13 objects. Find the number of distinct ways for doing so. Let me explain. See, 30 objects are to be divided into 3 groups containing 7, 10, 13. Now, from 30 objects, first we select 7 objects to form first group. So 7 objects can be selected in how many ways? Don't write. Let me explain first. In how many ways? 30 C7 ways. So how many are left? 23, of which 10 are to be selected. So this can be done in 23 C10 ways. Now how many are left? 13, of which all are to be selected. So this can be done in 13 C13, that is 13 factorial way. I'm sorry, that is 1 way. Now 30 C7, 30 factorial upon 23 factorial into 7 factorial into 23 factorial into 13 factorial into 10 factorial, and this is nothing but 1. So if you simplify this, what remains is 30 factorial upon what will be denominator, 7 factorial into 10 factorial into 13 factorial, because 23 factorial gets cancelled. Yes, your observation is correct. It is the same if we use that result, permutations of n things taken all at a time, but all of them are not distinct. But here you have to write explanation in this manner. Right done. Write the solution. 30 objects are to be divided into 3 groups. 30 objects are to be divided into 3 groups containing 30 objects are to be divided into 3 groups containing 7, 10, 13 objects respectively. Next line. From 30 objects, 7 can be selected. From 30 objects, 7 can be selected in 30C7 ways. 30C7 ways. Full stop. From the remaining 23 objects, we select 10 for the second group. We select 10 for the second group in 23C10 ways. 23C10 ways. And lastly, from the remaining 13 objects, we select 13 to form the third group. We select 13 to form the third group. We select 13 to form the third group. Therefore, total number of selections equal to see and write this 30C7 into 23C10 into 13C13. This is actually not selection, this is compulsion. So one way. Now only 23 factorial gets cancelled. So this is the final answer. 30 factorial upon 7 factorial into 10 factorial into 13 factorial. Right. So that's it for today.